And I guess I'll first get a general survey from everyone here if there were any particular problems that you wanted to see me work through. And again, I sent out like a PDF of about 11 problems in the email to you guys about this exam review. So maybe hopefully you guys took a look at it. If you don't have any particular problems, then I'm just going to start, just randomly working through some of them. And then you guys can ask me questions as I'm going through those problems. Okay? Okay, all right, so, all right. In that case, I'll just go ahead and get started. So I have problem 1 up right now. Let's just start working through problem 1. Again, please post a message in the chat or unmute yourself and speak up if you want to say something.
Hello, can you hear me?
Yes, I can hear you, yes.
Yeah, I just wanted to ask, after I think you mentioned that we would be given a PDF of these questions. So, is there going to be an answer key alongside that we'll be given, or do we have to look up this recording and see how you did them?
Yeah, so I was actually planning on making a answer key for this as well. It would likely just be answers though, because it takes a long time to type out solutions to problems.
Yeah.
But at the very least, I do plan on giving an answer key with the answers, so you can at least kind of verify if your work was correct or not. Okay.
Okay, I see. And also, since this is being recorded, where can we access the recording for this session?
Sure. So I'm going to upload it to our YouTube channel, and once I've uploaded it, I will email a link to it to everyone. Okay.
Gotcha. Thank you.
All right. No problem. All right. So let's take a look at this first problem here. So we're given 2 points, and we're told that they form a diameter of a circle. So I'll draw a little picture of these 2 points right now. Whoops. Okay, let's switch colors. All right. So I have 1 point at 2, 5. Okay, so let's see, this is my x-axis, my y-axis. 2, 5 should be, well, up here. It's maybe a bit too high for the picture right now. And then we also got a midpoint, which is -4, -1. So let me see here. In my picture, that would be right here, -4, -1. Okay? And so these guys form a diameter of a circle. Yeah, move it further out here. Okay. And so then I'll try to draw like a circle going through those 2 points. That wasn't so great, but that should be good enough, all right? Okay, so then we form a diameter of the circle is what we're told. Okay. So first things first, we're asked to find the coordinates of the center of the circle. And so if these 2 points form a diameter, then the midpoint between them should be the center of the circle. So what we'll do is we'll calculate the midpoint between A and B. All right, and so to calculate the midpoint between 2 points, do you guys remember how to do that? Okay. Yes, that's right. So you just average the 2 points in order to get the midpoint. So what we'll do is we'll add the x coordinates together. So we're going to add 2 plus -4. And then we're going to divide by 2 to get the average. And then similarly, we'll add the y coordinates together. So 5 plus -1. And then again, we'll divide by 2 to get the average. So that's going to leave me with negative 2 over 2, which is negative 1, and 4 over 2, which is 2. All right, so we got the center of the circle now. The picture's a bit off, but I guess it's kind of close to negative 1, 2, right? Okay. But that's how you would do part A. Again, if you guys have any questions, just let me know. Okay, what if we wanted to find the radius of the circle?
You could use
I guess,
this formula.
Yeah, that's right, yeah. So we can use the distance formula, and what we can do is get the distance between one of the endpoints together with the center. So let's see, let's say the radius, I'll calculate it as being the distance between point A and the center, which I guess I'll call it C, okay? All right. And you guys remember the formula for distance?
The square root of x2 minus x1 squared plus y2 minus y1 squared.
Yeah, perfect, okay. All right, so let's see here. If C had coordinates negative 1, 2, and we had coordinates of 2, 5. Okay, so if we do x2 minus x1, let's do 2 minus negative 1. Whoops, minus negative 1, which is plus 1 squared. And then we're going to do plus y2 minus y1, so we'll do 5 minus 2. Sorry. Okay. So let's see what that gives us. We're going to get 3 squared, which is 9, plus another 3 squared, so another 9, so square root of 18 altogether. That gives us the radius, okay? All right, now, I kind of suspect square root of 18 is an acceptable answer, but if you do want to simplify this, what you could do is you could say that square root of 18 is square root of 9 times square root of 2. And square root of 9 is equal to 3. So then you could simplify it as 3 times square root of 2. I don't actually know your professor's preference, but at least for me personally, I would say either of these answers should be sufficient. Okay?
Hey, why wouldn't it be negative 4 minus 2 squared plus negative 1 minus 5 squared? Because I thought it was like x2 minus x1, like negative 4 minus 2 squared.
Uh-huh. So I think what you're doing is you're calculating the distance between points A and B, right?
Yeah.
Okay. So the issue is that A and B form a diameter of the circle. So if you calculate the distance between A and B, you wouldn't have gotten the radius, but you would have gotten the diameter instead.
Do you not just do that and then divide by 2?
Okay, yeah. So you could do that to get the radius. You would have gotten the same answer as what I did over here then, okay? All right. Yeah, so that is another way you could do the problem. Instead of using points A and the midpoint that you calculated in part A, you could have just used A and B, calculated the diameter, and then divided by 2, okay? All right, good question. Okay, she usually does want you to simplify. Thank you. So in that case, yes, square root of 18 you can simplify as 3 root 2, and it sounds like that might be what your professor would prefer to see, okay? Yeah, so then let's talk about getting the equation of the circle next. I see. Yeah, so you could get the equation of the circle, and then if you manage to get the equation of the circle, you could also read out the radius from the equation. But it might also be easier to have calculated the radius first in order to get the equation of the circle. Although you can certainly get the equation first before getting the radius, that is certainly possible. Okay. All right. But yeah, so standard. Oh, yeah. So the standard form for the equation of a circle. Let's talk about what that looks like. So the standard form for the equation of a circle looks something like this. So it's x minus h squared plus y minus k equals r squared, where h and k are the x and y coordinates at the center of the circle. And then, of course, r is the radius. Okay? So I guess here we've already found both the center and the radius. So we can just plug those numbers in to the equation to get the equation of the circle. So in this case, h and k would be the -1 and 2 that we found for the center. So x minus h would be x minus -1. So that would be x plus 1. And then y minus k would be y minus 2. The radius we found was 3 root 2, or maybe if you prefer square root of 18. So it would have been square root of 18, but then squared again. And then, of course, the square root of 18 squared will just give you 18. So here, this would be the equation of our circle. All right, any questions about that? All right. Let's go through just parts D and E then. So getting the x-intercept and the y-intercept. Do you guys know how you would find the x-intercept of the circle?
You could just make y equal to 0.
Yes, perfect, okay. So the x-intercept is when y is equal to 0. So if we take the equation of the circle, and if we plug in y equals 0, so that's going to give us x plus 1 squared plus 0 minus 2, so -2 squared equals 18. So what we can do here is we can solve for x. That's going to be 4. Move the 4 over. All right, now at this point, if I want to solve for x, what we could do is we could square root both sides. But keep in mind that here you have two possible solutions when you do this. So you could have x plus 1 equals 14, or you could also have square root of 14, or you could have x plus 1 equals square root of 14. Okay? So when you're solving for x in an equation like this and you square root, Keep in mind that you need to consider both the plus and the minus square root. All right, so then we get x is square root of 14 minus 1. Or we also have another x-intercept where x is minus square root of 14 minus 1, okay? So we have two x-intercepts in the end. So one where the x-coordinate is square root of 14 minus 1. And then again for the x-intercept, the y-coordinate is always 0. But then we have another x-intercept where x is minus root 14 minus 1. And then again the y-coordinate will be 0 for an x-intercept.
Can you scroll up a little bit?
Yes. Is that good?
Yeah, I was
Okay,
just
all right.
trying to see the whole process.
Sure, okay.
Yeah, I got it. Got it. Thank you.
All right, perfect. All right, so to get x-intercepts, you want to plug in y equals 0 and then solve for x. So then if you want to find the y-intercepts, its process is similar. You just want to reverse the rows of x and y sort of. So for the y-intercept, what you're now going to do is you're going to plug in x equals 0 into the equation instead in order to solve for y, okay? And here is the equation of the triple. And now we're going to plug in x equals 0 to get the y-intercept. So that means when x is 0, you'll have 1 squared. And of course, 1 squared is just 1. So if we minus the 1 to the other side of the equation, here you'll get y minus 2 squared is 17. So then when you square both sides, you're going to end up with two possibilities. So y minus 2 is the square root of 17, or y minus 2 is minus root 17, okay? So then you'll have two y-intercepts as well, where y is 2 plus root 17. And then when y is adding the 2 over 2 minus root 17. Okay? Right, so then ultimately, two y-intercepts. So the x-coordinate will be 0 for a y-intercept. And then one of them had a y-coordinate of 2 plus root 17. The other one had a y-coordinate of 2 minus root 17.
Can we put the 2 at the end? So we'll have root 17 plus 2 and then negative root 17 plus 2.
Yes, that would be perfectly fine as well, okay?
Okay, thank you.
Yep. All right, so that finishes problem 1. So if you guys don't have any other questions, I could move on to problem 2. And so do you guys, so when I sent out the email again, I attached the PDF of the problem, so I'm gonna go on to problem 2 unless like everyone here says, oh, I'm fine with problem 2 and let's go on to problem 3 or something. Okay? All right, let's go on to problem 2 then. So in problem 2, we're given this function f of x equals 1 over x squared minus 5. Okay. So the first thing we want to do is find the domain of f. Alright, so how do you guys go about finding the domain of a function? What do you guys usually do?
Set the denominator equal to 0.
Yeah. Okay, good. So,
Solve.
Yeah, okay, yeah. So when you do that, so remember that you can't divide by 0, right? So if the denominator is 0, that's bad. So we're going to look for the places where the function is undefined right now, by checking whether the denominator is 0. Places where the function is not defined, those are points that you want to exclude from the domain. So it's sort of like in order to find the domain, you find what's not in the domain, and then the domain would be everything else, is kind of the idea. Okay, so we check whether the denominator is 0. So here, if you solve for x, you'll get x squared is equal to 5. So you'd have x is positive root 5 or negative root 5. Okay? So then these numbers that we just found, these numbers are not in the domain. Okay, but aside from where the denominator is 0, our function should be defined everywhere else. So then the domain of f should be every number except these two numbers, where the denominator becomes 0. Okay, so to express the domain using interval notation, it might help to draw a little visual. So let's say here I've drawn a number line, okay? And we have these 2 points, square root of 5 and negative square root of 5, which are not in the domain. So I'll kind of just mark them somewhere in the number line that I've just drawn. So maybe that's minus root 5. And here this would be root 5. Okay? So we want to remove these points from the domain, but everything else should be in the domain. Okay? Okay, so that means everything to the left of minus root 5 will be in the domain of f. So then we can express that as an interval from minus infinity up to minus root 5. Okay. And I want to use parentheses for the interval because I do not want to include this point, I want to exclude it. So the parentheses means to exclude the endpoint. And remember that if you wanted to include an endpoint, you would use brackets instead, okay? All right. Now that's just one part of the domain though. So we also have everything between minus root 5 and root 5, which should also be in the domain of f. So I'm going to union the interval of everything between minus root 5 and positive root 5. Again, I use parentheses because I want to exclude my two endpoints. Okay. And then there's one more part to the domain, which is everything from root 5 outwards to infinity. So in addition, I'm also going to union the interval starting at root 5 out to infinity. Okay. And then again, parentheses to exclude the endpoints. All right? Okay, any questions about that?
Can you scroll over to the question, the screenshot of the question?
Yes.
Okay, so if we had, for example, x minus 5 in the denominator, then we would simply write the domain of f as negative infinity, comma, 5 union 5, and then 5, comma, infinity, right?
Yes, that would be correct.
Okay, yeah, I'm just making sure because like I'm used to doing those problems, and for this one, of course, we have to use the
Yes.
so yeah, it's a bit different.
Exactly. Yeah. Yes. So here, it was a bit different then because there were 2 points that you had to like remove from the number line to get the domain. So then it broke the number line into 3 intervals that you had to union all of them. Yeah. So I guess in general, the domain of a function is the set of x values for which your function is defined. So usually the strategy for finding the domain of a function is to find the places where it's not defined, and then the domain would be like everything else. Okay. And sort of the main thing that you look out for is where the denominator is 0, because when the denominator is 0, the function would be undefined there. Okay. All right. Part B, find the value of f of 2. How do I do that?
You plug in 2 for x.
Yeah, exactly. Okay. So that's pretty simple. Let's just do that real quickly. So f of x is 1 over x squared plus 5. So just plug in, oh sorry, it was minus 5, right? So just plug in 2 for x. And so here it's 1 over 4 minus 5. So 1 over negative 1, which is the same as just negative 1. Okay? Perfect. All right, as for the coordinates of the y-intercept of f of x, all right, how do I do that?
Set x equal to 0.
Yep. So it's kind of the same as what we did with the previous question. So y-intercept occurs when x is equal to 0. So what we'll do is we'll plug 0 in for x. Whoops. So it'll be 1 over 0 squared minus 5. So that would just be 1 over negative 5. Maybe if you prefer, you can write it as negative 1. So then the function gives you the y-coordinate of the y-intercept. And then the x-coordinate would have been 0, so the coordinates altogether would be 0 and minus 1 over 5. Okay? All right. Now one more part to the problem, which was find the values of x for which f of x equals 1 over 11. Okay. So our function is 1 over x squared minus 5. We want to find the values of x for which f of x equals 1 over 11. So we can go ahead and just take our function and set it equal to 1 over 11, and then we want to try to solve for x, okay? So to solve for x, what would I do here?
You could cross multiply and then solve for x.
All right, great, yes, okay. So we can cross multiply, so multiply x squared minus 5 over to here. Multiply 11 over to here. And then, yeah, just solve for x now. So add the 5 over to the other side. So in solving for x, we'll square root it. But we get two possible solutions, right? So x could be square root of 16, or it could also be negative square root of 16. So that gives you two solutions altogether. X could be either 4 or negative 4. Okay. All right, good. Any questions about this problem? Okay. Let's maybe take a look at problem 3 next then. Alright, so yeah, let's see. This problem, it is pretty similar to problem number 2. Maybe a little bit simpler, perhaps, because the denominator is just x minus 3. So would you guys like to skip on to problem number 4? Or maybe is there like 1 or 2 parts to this problem that you would like to see in particular? So maybe we don't have to work through the entire problem at least.
Can we do 3C?
3C. Okay, let's do 3C. I guess that would be the hardest part of the problem, I would say, myself. Okay, so find the values of x for which f of x equals 7. So what we want to do is take our function f of x, we want to set that equal to 7, and then we're trying to solve for x, okay? Alright, so now how would I solve for x from this equation?
We cross multiply?
Yeah, okay. So what you can do is, yeah, multiply the x minus 3 over to the other side. So then at this point, we want to solve for x. So in an effort to move all the x's to one side of the equation, what we'll maybe do first is we'll distribute the 7 into the parentheses with 7x, and then 7 times 3 is 21. Okay? Good. Alright, so now we want to move the x's to one side and everything else to the other side. let's maybe I'll minus the 2x over to here. So 7x minus 2x gives us 5x. I'll add 21 to the other side. So we'll get 1 plus 21, which is 22. So finally divide by 5. And so you'll get x is 22 over 5, okay? All right. Any questions about that?
You probably mentioned this before, but have you already sent out a file that contains all these questions? Because I didn't get anything in my email, or where is the file containing these questions?
Okay. Yeah, so did anyone get the file at least? I don't know if I possibly forgot to attach the file to my email. Okay, all right. Yeah, it was attached to the email that I sent out. When I send out the link to everyone to the recording of this review, I can go ahead and reattach the file to that email though, and that way we can make sure that everyone has a copy of it, okay?
Thank you.
All right, no problem. All right, so let's take a look at problem number 4 then. Number 4. Oh, okay. All right, so we have this function here involving absolute value, and we want to graph this function, right? Okay. So maybe how would you guys go about trying to graph this function? What would you do?
Set up a table and use have x values like -2, -1, 0, 1, and 2, and then solve for y, and then graph those points.
Okay, all right. All right, so let's see here. So we're going to set up a table. So yeah, we'll pick some points for x. Do you guys have do you guys just choose random points, or do you guys maybe have a way of choosing specific points, just out of curiosity?
I tend to pick -2, -1, then 0, 1, and 2. Just a couple of points.
Okay. Okay, all right. Okay, all right. So let's go ahead and start with that, okay? So I just kind of want to make sure that I also do the problem kind of in the way that you guys are expected to, okay?
Also rearrange the function. So can you just say that it's -2, the absolute value of x plus 4 plus 3 as the y-intercept, or no?
That's what I did.
So you could rearrange the function as -2 times absolute value of x plus 4 and then plus 3. So that would be equivalent to what we currently have. Okay. Now, in order to, maybe just real quickly, so you talked about the y-intercept, right? How would you find the y-intercept of this function?
Set x equal to 0.
Okay, all right. So if we set x equal to 0, well, let's just maybe check what the y-intercept was real quick. So negative 2 times absolute value of 0 plus 4 plus 3. Okay, so then, of course, absolute value of 4 is just 4. So that's negative 2 times 4, which is negative 8. And then plus 3. Okay, yeah, so the y-intercept is negative 5, right? So that will give us one of the points on the graph of our function. Let's see. I'll start trying to graph it here. And I have these graphs, grid lines. Why don't I use them? Okay. All right, so we have when x is 0, the y should be negative 5. About 1 point down there right now. Okay. And so, yeah, we want to plot a couple more points, so let's go ahead and do the negative 2, negative 1, 1, and 2 as well. Okay, so when x is negative 2, so I guess I'll do those over here. So f of negative 2 would be negative 2 times the absolute value of negative 2 plus 4 plus 3, okay? Right, so that's negative 2, that'll be times 2 plus 3. So negative 4 plus 3 is negative 1, okay? So then the point negative 2, negative 1 is another point on the graph. So negative 2, negative 1. All right, perfect. All right, if we do f of negative 1, so now plugging in negative 1 for x, so minus 1 plus 4 plus 3. Okay, so negative 2 times 3, so that would be negative 6, plus 3 is negative 3. Okay. All right. So then when x is negative 1, the y-coordinate will be negative 3. We have those 3 points right now. Now f of 1, if we plug in 1 for x, negative 2, absolute value of 1 plus 4 plus 3. So negative 2 times 5 plus 3. So we get negative 7, right? Okay. So then when x is 1, we're going to go down to negative 7, so down here. And finally, let's just, I guess when x equals 2. So when x is 2, we wrote down negative 2 as the value of 2 plus 4 plus 3. Okay, so negative 2 times 6 plus 3. So it's negative 12 plus 3 should be negative 9. Okay? Okay. So then we could go ahead and start plotting. Well, now that we've plotted these 5 points, we can sort of connect them to begin getting a graph of the function f, okay? So that's what we have right now. Do you guys have a sense for what the graph of f should look like?
It will be like a V
If
shape.
it's
Okay. So yeah, I heard that it should be like a V shape, and that is correct, and that's because you have the absolute value there, right? Okay. So what we have is not bad, but I guess it doesn't give a full picture because we know it should have the shape of a V, and right now we, I guess, don't have that shape just yet. We only have like one side of the V, it looks like, right? So maybe it would be a good idea to graph a little bit more in order to get a better, fuller picture of the graph of f. So if we maybe take a look at part D of this question, which is how does the graph of f relate to the graph of the absolute value function? So I'm kind of jumping to part D at the moment, but the reason why I'm doing that is because I think that does help in getting a picture of the graph, right? Looking at the formula for f, could you guys maybe try to answer part D for me? Like, how does it seem like the graph of f would relate to the graph of g? Can you tell?
It's shifted up 3, and it would be stretched vertically by a factor of 2.
Okay, yeah, those are good observations. What else?
it's reflected over the x-axis.
Yeah, because of the negative in front of the absolute value, okay. There's one more thing as well that you can take from the expression for f. So you said shifted up 3, that's an aspect of it. Reflected across the x-axis.
Move to the left 4.
Yeah, shifted left 4 because of the x plus 4, right? Oops. So it's shifted left 4. It was stretched vertically by 2. I don't know why you wrote it over there. Okay. Reflected about the x-axis because you had a minus sign in front of the 2. And then shifted upward 3, right? Okay. Alright, so then we can use that information to help us in getting a full picture of the graph of f. So the absolute value function, right? Let's see here. So we know absolute value function has this V shape. So if I shift it left 4 units, that means the new graph, so shift left 4 units, it'll have its vertex at negative 4 then. Okay? So we sort of missed the vertex up here because we started at negative 2. Do you guys see that? But the vertex should have started at negative 4. So let's go out to negative 4 to get to the vertex. So if I kind of continue this pattern, going up like that, no, that's not quite right. Let me see. So here we were kind of sloping down 2 and over 1 every time. So if I move over 1 and then up 2, that would be the next point. Over 1, up 2, that would be the next point. All right. So yeah, at negative 4, that's where the vertex of the graph of f should be. And then we can sort of mirror what we've drawn now, but on this side. So if I go down 2 over 1 this way, and then down 2 over 1 this way, and so forth. With that, you're able to get a more complete picture of the graph then, okay? Whoops. More like this. More like that. All right. So I think when you have a question like this, it's a good idea to, so certainly you can make the table and figure out some of the points on the graph. But I think it also helps to make this analysis as well. It'll kind of help you to at least see like some particular points that you'd want to calculate. So like here, observing that the vertex was at negative 4, because it was shifted to the left by 4. What you might have done is you might have graphed like negative 6, negative 5, negative 4, negative 3, and negative 2. And that way you would have actually gotten the beginnings of the V shape. And then you could have just like extended it further to get like a bigger picture if you wanted. Okay? All right. So any questions about what I've done so far?
So I
Yes.
know this ends at, sorry, this isn't related to the question, but
No.
I know this ends at 12, but I unfortunately have to leave at like 11:30. But do you think you're gonna get like to the bottom of the review, like question 10 specifically?
Yeah, I definitely hope to get to, I'll probably 9, 10, 11, I'll probably hope to work through in the review, because I know those were delving more into the more like trigonometric part of this exam. So yeah, I will definitely look at those last 3 problems, I would say, okay?
Okay, awesome. Thank you.
All right, no problem. And yeah, if you do need to leave early, no, I'm not going to force you somehow to stay. So if you need to leave early, that's perfectly fine. You can let me know just by posting in the chat, perhaps. You don't need to let me know at all, though, as well. You can just like leave when it's time. That's perfectly fine, okay? I won't feel offended or whatever. So, all right. There are, I guess, 2 other parts to the question, finding the domain and the range of f. So let's also just look at those 2 aspects. What's the domain of this function?
Would it be negative infinity to infinity?
Yeah, okay. Here it's just it's pretty simple. It's just minus infinity to infinity. That's kind of the best you could sort of hope for, I feel like, for the domain. Yeah, there's no point where the function will be undefined. Okay. You didn't have to worry about dividing by 0 or anything like that, because there is no denominator. So yes, the domain will just be minus infinity to infinity. Good. What about the range of the function?
Negative infinity to 3.
Yes, okay. So the graph only helps you in seeing what the range would be. So the range was all the y values of the graph of your function. So you see the y values go down to negative infinity, and they're capped off at the top at 3. So yes, the range would be negative infinity to 3. Now notice here 3 is in the range, so you'd want to close it off with a hard bracket though, as opposed to a parentheses. Okay? Okay. And they probably want it written with negative infinity on the left and 3 on the right, because that's kind of like the order, like left to right. Negative infinity is smaller than 3. So you'd want to like write negative infinity on the left and 3 on the right instead. Okay? All right. Now before I go on to another problem, I want to say one more thing, which is regarding part D, okay? And so again, it was kind of good to do part D sort of at the beginning to help in getting the graph of f. But also the order that these things are done in is important. So you guys kind of explained all these different things that were happening to the graph of the absolute value function to get to the graph of f. But you guys kind of gave them all like sort of randomly, if you will. But the order that each of these things is done in is important. So like if you let's see here. Now, some of these things are not as important, but some of them are. So this one, if you shift up by 3, yeah. So like here's one good example. So here I talked about how you shift to the left by 4 first, then you stretch it vertically by a factor of 2, then you reflect about the x-axis, and then you shift upwards by 3 is what I said, right? So in particular, if you reflect about the x-axis, so that it would open downwards, and then you shift it up by 3 after that, so then it starts kind of like a little bit higher. Notice that's a little bit different from if I shift upward by 3 first and then reflect. So let's say if I took this and I shifted it up by 3 first, and then I reflected, I would have gotten a graph that was starting down here, whereas the graph should have started at the top, okay? So if you do these 4 items in the wrong order, it actually won't give you the right picture. So do you guys know how to determine like the order that these items should have been done in to get the graph of f? Okay, so the way that I do it is I base it off the order of operations, okay? Because if you think about it, when we have this function, f of x is, so it was negative 2 times the absolute value of x plus 4 and plus 3. Alright, so if we were to go by like the order of operations, we would start with like what was in the absolute value first, right? meaning you should start by shifting the graph left by 4 first, okay? Then multiplication takes precedence over addition. So multiplication by -2 leads to stretching by a factor of 2 and reflecting about the x-axis. So these two steps should come before the upwards shift by 3. Adding 3 would have been like the last step in the order of operations. So then that's why shifting upwards by 3 should have been the last step in order to get to the graph f. Okay? So to figure out the order in which these items need to be performed in, you can base it off the order of operations. Okay?
So is the order of operations just PIMDAS, or however that?
Yeah. Mm-hmm. Yes. And I guess I would say that regarding like how parentheses comes first, right? Maybe just like including that things like absolute value, or maybe like if you had a square root, consider what's in the square root as like something in the parentheses as well. Okay. Okay. All right. So I don't know if your professor would. Like maybe your professor just wants you to see the 4 items listed and then maybe don't care about the order that you listed them in. But technically, the steps that you perform these different items in will affect the end result. So if you want to list them in the proper order, you can base it off the order of operations, all right? So any questions about that? Okay, all right. We'll take a look at problem 5 then right now. Let me see what problem 5 was. Okay. All right, so are there any particular parts of problem 5 that you'd like me to take a look at? Or any questions about problem number 5?
Do you mind writing the domain of the functions?
Yes, Let's go ahead and write out the domain. All right, let's see here. So it's a little bit complicated. Okay. So our function is defined for x less than -2. So we're going to have everything from -infinity up to -2. That's one part of the domain. Here, notice it stops at x being like strictly less than -2. In other words, it's not including -2, and that's why I use parentheses there. Okay, -2 was not included. The next interval, though, is it's also defined for x between 0 and 3. So that will give me another interval in the domain. Looks like 0 was included. 0. So because it's included, I would do a bracket for 0. And I'll go up to 3.
But don't we
Okay.
say
That,
the third function?
okay, yeah, so, yeah, can you say that again one more time?
Don't we see that 3 is included in the third function?
Yes, okay. Yeah, so notice here that, although 3 was excluded here, it's included next, okay? So, when I look at this, these two parts of the function, you have going from 0 to 3. And then at first, it looks like 3 is not included, but when you look at the next one, you see that 3 is actually still part of the domain, going up to 8. And let's see here, it looks like 8 is altogether excluded though. It's not in here or in here. Alright, so rather than writing like 0 to 3, union 3 to 8, okay, you could write this part as 0 to 8 altogether. Okay. So there's a reason to kind of stop at 3. If it's included, you may as well just continue past 3 and go straight to 8 instead. And then, yeah, also for x greater than 8, so you would also union everything from 8 to infinity. So this would be kind of the most simplified form of the domain written out in interval notation. Okay.
Thank you.
By simplified form.
What was that?
I'm sorry, what did you mean by simplified form?
Okay, so I guess in the sense that I've written that here is also, in a technical sense, a correct answer. But it's not as, it doesn't look as simple as what I've written down here, right? Because here I've sort of like merged these two intervals into like one larger interval. So here this looks a little bit simpler, 3 unions, or 3 intervals being unioned together, as opposed to up here where you have like 4 intervals unioned together. Okay?
Yeah, the bottom one looks simpler, and but if we were to answer the top one in the exam, would my math lab do it correct?
Oh, would my math lab consider that correct? What a good question. I think, in my experience observing how my math lab works with students, I feel like my math lab was fairly flexible in being able to recognize when an answer was like equivalent to the correct answer. So I would lean towards saying that my math lab would probably count this as being correct. But I can't say with 100% certainty though. But if I were to lean one way, I would say it would probably count this as correct though. Okay? All right. Were there any parts to part B that you wanted to take a look at in particular?
Can we do part B number 4?
Yeah, okay. So maybe why that you want me to take a look at part 4 specifically? What do you notice about part 4?
The 8 is in 2 different inequalities.
Okay, yeah. So to determine like which part, like which formula that you'd want to use to get f of 8, well, you'd want to see which part includes 8. Okay? So whichever part includes 8 would be the part that you'd want to use to evaluate the function. But if you take a closer look, you notice that neither part actually includes 8, right?
Yeah.
Okay. So the issue then is that 8 is not in the domain of your function, right? It was outside of the domain. So in other words, that means you would answer that the answer does not exist. Yeah, okay.
I thought first I would have thought that we would use the lowest one because it actually has an x value where we could plug in 8, but that's not,
Okay, I see.
yeah.
Yeah, that's not quite correct then. Okay, yes.
one of these inequalities was x is equals to or greater than or less than or equals to, then we could have used that, right?
Yes, So maybe like as an example, so let's say if it were x less than or equal to 8, okay? Then, so if we had an equal sign, oh, okay, here, then you could have said that f of 8. So when x is 8, you would use this for your function. And there's no x here to plug into. But what that means is that it would just be equal to 5. Okay? Since there are no x to plug into, you would just have gotten an answer of 5 because of that. Okay? Number 7? Yes. Oh, okay, yeah. In fact, number 7 kind of illustrates the same idea. Well, I'll use black. Yeah, so number 7 is asking for f of 3. And 3 also appears in 2 locations. But in particular, 3 is included in this portion. So you'd want to use this formula for f to evaluate f of 3. And when you plug in 3 into here for x, since there's no x to plug the 3 into, you will just get the answer to be equal to 5. Okay? I kind of thought that might be the case, but I also thought I would just look at items number 7 here anyways, because it did tie into what I just talked about. But yeah, okay. All right, so I think, yeah, let's go ahead and go on to number 7. I just took a quick look at number 6, though, to see what that was. Okay, all right. So I might come back to 6 in a bit, but since I just got a request for 7, I think I'll jump to 7 first at least, okay? Okay, all right. Yeah, so here we're asked to find the inverse function, okay? That's what f to a power of -1 represents. Represents like the inverse function, not like the reciprocal, okay? All right, so this is kind of a general technique for finding the inverse of a function. Do you guys remember what that technique was? Yes, okay. So what I'm going to do here is I'm just going to rewrite my function as an equation. I'll rewrite it y equals instead of f of x equals. And now what you want to do in order to find the inverse function is you want to swap all your x's with y's and your y with an x, okay? So then instead of y equals, we're now going to have x equals. And then all of these x's are going to be replaced with y's. Okay? After swapping the x and the y, now what you want to do is just resolve for y. Okay, so it's a little bit complicated perhaps right now, but if you want to solve for y, We've kind of done this before. You want to multiply the denominator over first. Get rid of the fraction. Okay. And so we're going to want to get all the y's on one side and everything else over to the other side. So to do that, we need to kind of get this y out of the parentheses, and to do that, we'll distribute the x. Okay. So if you distribute the x, you're going to get 3xy minus x equals y plus 2. Okay. And so to solve for y, again, you want all the y's on one side to start with. So maybe what I'll do is I'll minus this y over to the other side. Okay. At the same time, I'm going to go ahead and add this x over as well. So I have 2 plus x, or x plus 2, whichever you prefer. Alright, so yeah, trying to get all the y's on one side and trying to get everything else on the other side is what we're going for. Okay, now, to solve for y, what would I do at this step? Now, who can tell me what to do at this step? Yeah, okay. Once you get all the y's on one side, what you'll be able to do is you'll be able to factor it out from every term. So factoring out a y from every term over here will leave us with a 3x in the first term. And we're still going to have a minus 1 remaining in the second term after you factor out the y. Okay. And now that we've factored out the y, we can now just divide this term over to the other side. That finally gets us the answer for y. And maybe the last thing you want to do is once you solve for y like this, if you now just rewrite it, replace y with f inverse of x. So then this would be the formula for x inverse. All right. So then, yeah, just a quick recap is take your function and write it as y equals instead of f of x equals. Swap all the x's and y's, and then solve for y. Okay. Solve for y by getting all the y's on one side and everything else to the other side. Once you've done that, you factor out the y, divide, and at the end, replace y with f inverse of x. All right. All right. Any questions about that? Okay, let's see here. I think what I'll do is I'm going to jump to looking at problems 9, 10, and 11, okay? So that's what I'm going to be going through next. And then perhaps after those three, I might be back around to 6 and or 8. But I did want to look at 9, 10, and 11 in particular. Because as I was kind of talking about earlier, this is kind of where you start the trigonometry part of this course, okay? All right, so here's problem number 9. So, I changed the problem slightly actually. So, for those of you who are maybe looking at problem number 9 in the PDF, I think I used centimeters or something for the units in one of the questions. But your professor asked me to stick with like inches and feet and miles instead, which I guess is appropriate because that's kind of like the stated units that we use in this country. Okay. All right, no problem. So in all the problems where I had like centimeters or something, I changed it up slightly, whereas I used like inches or something else instead. Okay. So when I send out the email with the link to the video recording, I'll actually attach the new problems that I created, where for the most part all I did was change like centimeters to inches or something like that. Okay. All right. So let's take a look at problem number 9. So part A, let's see what we are given. We have an angle theta, and it's the central angle of a circle with diameter 10 inches. So I'm going to draw just like a little picture of what that means right now. So let's imagine we have this circle. Whose diameter is 10 inches. And when it says that theta is a central angle, that just means that you want to imagine the angle theta with like the vertex starting at the center of the circle. So yeah, I'll maybe just draw like a generic picture of this. Maybe I'll draw it like that. It might be inaccurate, but that's okay for the moment. Okay. So here I've drawn a central angle, meaning an angle whose vertex starts at the center. And I've labeled that angle theta as described in the problem. And then it says, suppose the arc associated with theta has a length of 13 inches. So when they talk about the arc associated with an angle theta, they would be referring to the arc that the angle makes along the circle. So it'd be referring to this arc here. So that arc is supposed to be 13 inches long. All right. Okay, so my picture is not drawn to scale, so maybe I'll draw a better picture once we work out the problem. But 13 inches, I guess, should be longer than a diameter, so it should be maybe a bit more along somewhere here. But I'll redraw the picture once we figure out what theta should be, though. Okay. For now, it's okay that the picture is inaccurate. What we want to do is we want to find the angle measure of theta, and we want the angle measure in degrees as well. So with the information that we're given, who can tell me how we would find the angle measure of theta?
Use the equation theta is equal to s theta over r.
Okay. All right, yeah, okay. So you have this equation that will give you the angle measure of an angle theta in radians, right? Which is that the angle measure of theta is equal to the ratio between the arc length. I guess I think you guys were calling that s theta. And then over the radius of the circle. So So that's the arc length over the radius, okay? And so what we can do is just take the arc length, which was 13 inches, divided by the radius, which would have been 5 inches, right? Because the diameter was 10, okay? So this will leave you with a radian measure of 13 over 5 for the angle theta, okay? Yes, okay, that's correct. Yes. All right. Now, we have the angle theta in radians, but the question was asking for theta in degrees instead. So what we need to do then is convert from radians to degrees. Okay. So how do we do that to convert from radians to degrees? Alright. Yes. Yes.
You can take, since it's radians, we can take the 13 over 5 and then do like additional analysis and multiply it times 180 degrees over pi.
Yes, okay. So what you can keep in mind is in terms of how radians relates to degrees, pi radians represents the same angle as 180 degrees, okay? So knowing this will help you to convert from radians to degrees or degrees to radians. Alright, so then if we do the dimensional analysis, as was suggested, so this is 13 over 5 radians right now. So if I want to get it into degrees, maybe I'll emphasize radians. Okay. We can multiply by 180 degrees over 5 radians. Okay. So that way the radian unit kind of cancels out. So ultimately we're going to do 13 over 5 times 180 degrees over pi. And, oh dang it. Alright. Does anyone have a calculator? And so can you tell me 13 over 5 times 180 over pi? Let's see what that is. 13 over 5 times
It's
180.
148.97.
Okay. $148.97. Oh, is that green? Or is that black? I think that's green. Oh, okay, whatever. Sorry, what was saying again? 147 was it?
I got 48.97.
Thank you. Okay. So does anyone have any questions about that?
Okay. Can you scroll a little bit to the left?
Yeah, here, I'll do that.
Thank you.
Okay. All right, so then beta is about 148-ish degrees. So I guess that picture wasn't so great, so it didn't matter too much for the problem, but I'd like to at least have an accurate picture in the video. So I'll just kind of fix it real quickly. So it should be a little bit more like here or so. And then this would have been the arc associated with data. Okay. All right. So if there are no questions, we can also take a look at part B, okay? So part B is a little bit similar. You were just kind of given, well, different pieces of information. So this time what you're given in part B is the central angle of a circle is now given to be 110 degrees. All right, so again, central angle means the vertex of the angle is at the center of the circle. So 110 would be a little bit more than 90, so something like this. Okay. We're also given the radius of the circle is 8 inches. Okay, so we know the radius is 8. We want the length of the arc. So then here's the arc associated with data. We want to know the length of this. All right, so to figure out the arc length, we can kind of use the same formula as before, except rearranged. So we'd have like S theta. It's R times theta. Okay. All right, so should I just multiply h by 110 to get the answer?
Does theta have to be in radians?
Okay, yes, okay. If you're going to use this formula only works when data is in radians. So maybe that's a key note about it. Okay. So therefore, we'll actually want to convert the 110 degrees into radians first before we apply the formula to get the arc length, okay? So we'll do kind of the dimensional analysis again. So starting with 110 degrees, and then using this conversion factor, so pi radians is 180 degrees. So we can multiply this by pi radians over 180 degrees. That will sort of cancel out the units of degrees, if you will. And that will leave you the answer in radians. So we'll have 110 times pi over 180. And maybe if someone could calculate that for me and tell me what that is, that would be really great. Okay, let me see. It was... Oh, okay. Well, I guess we can actually just keep an exact answer instead of using a decimal. Yeah, I don't know why I didn't think of that. So yeah, we could simplify 110 over 180 as now 11 over 18. Okay. All right, so this is the angle data in radians. All right, so then to get the arc length, we'll just multiply now. The radius was 8 inches. And times the angle data, which was in radians, 11 pi over 18. Okay. It would be inches, okay, because we were multiplying by 8 inches here. And I guess we can simplify that by applying the 8 over 18 part. So 2 goes into 8 4 times. Oh. And 2 goes into 18 9 times. So if I multiply the 4 with the 11, that will give us 44 pi. Then we still have a 9 in the denominator. So it'll be 44 pi over 9 inches as an exact answer, okay? And then if you wanted a decimal, you would take 44, multiply it with pi, and divide by 9. Okay? All right. Any questions about that? Okay. So then I guess the main things to know are this formula relating arc length, radius, and angle. And that this formula is only good when your angle is in radians. Okay? Yes, okay. So I'll loop back around to problem number 6. But I would like to take a look at 10 and 11 first, though, okay? So let me take a look at those first. Okay. Let's see here. Okay. So yeah, let's look at problem number 10 right now. All right. So here I changed the numbers up a bit because I wanted to use like imperial units of measure rather than like the international SI units of measure. So using my feet and miles instead of meters and centimeters. Okay. Okay. So what we're given in this problem is we have this bike with a radius of 2 feet. And we've edited down a 10-mile trail in a time span of 35 minutes, okay? Now, when it says that we've edited 10 miles, what you can interpret from that is that any point along the tire or the wheel would have moved around a circle, a total of 10 miles, okay? So that 10 miles kind of represents like the arc length that a point on the tire would have traveled, okay? All right, so I'll call that S for arc length. S we know is 10 miles. And I guess I should be careful with the units, so let me emphasize that here. So R is 2 feet. Okay. So then let's look at part A first, where it's just asking for the angular distance that a point would end up traveling in radians, okay? So to get the angular distance, we can use the same formula that we used in the previous question, that angle is related to the arc length and the radius, and that the angle is the ratio between them. Okay, so arc length over radius. So to compute this, arc length we know is 10 miles. The radius we know is 2 feet, okay? So is the answer just going to be 10 over 2? So is the answer just 5?
No, you have to convert miles to feet or feet to miles.
Yeah, that's right, yeah. You need to have a consistent unit, so either convert miles to feet or feet to miles. Okay, so 1 mile is how many feet?
5,280.
That's what I thought, but
We
just
need
want to confirm that.
to memorize this conversion, right?
So I was told that your professor will provide this to you.
Okay.
So yeah, so maybe don't need to worry about that. It should be given to you, is my understanding. Okay. All right. So then we'll want to convert that 10 miles into feet. So let's see. What we can say is we'll do 1 mile on the bottom. It's 5,280 feet on top. All right, so then the units cancel out, if you will. Okay. And what we're left with was 10 times 5,280 on top. And then on the bottom, we are dividing it by 2, like that. Okay? All right, so then let's go ahead and compute what this would be. Okay. So if you compute it, I believe it's 26,400 radians. Okay. So then that would have been the angular distance traveled by a point on the wheel of your bike. So it would have gone through a total angular measure of 26,400 radians. All right. Good. Okay, so part B wants to know the number of revolutions that the wheels of your bike are going to go through on this trip. So, who can tell me how to find, how many revolutions the wheels will go through?
Divide by 2 pi.
Okay, yeah. So here, the idea is one revolution just represents going around the circle once. Okay. And if you think about the angular measure that you would go through in one circle, so like if you go around the circle all the way once, that would be a total angular measure of 360 degrees or 2 pi radians. Okay. So one revolution corresponds to an angular measure of 2 pi radians. So what we can do then is take the angular measure that we calculated in part A, and right now that's in radians. We just want to convert it into a number of revolutions instead, okay? All right, so to do that, we'll use the idea that one revolution is 2 pi radians. Okay. So what we'll be left with is 26,400 pi over 2 pi rather. All right. So it looks like that's about 3,915.21. So then, if you want to round it to the nearest whole number, you would round it to 3,915. So then that would be approximately how many revolutions your tires went through on this trip. Okay.
I think I got so when I did 26,400 divided by 2 pi, I got 4,201 revolutions.
4,201?
Yes.
Okay.
I got that as well.
Okay. So it seems that there's more consensus on 4,201 then? Okay. All right, so make sure you type it in correctly into your calculator. So maybe in particular, I'm not sure if this was the issue, but when you're typing it into your calculator, what you might need to do is when you're dividing by 2 pi, make sure that you put parentheses around the 2 times pi to make sure that you're dividing by 2 pi altogether, okay? Okay. Well, let me go ahead and, since there's some discrepancy, I'll go ahead and calculate it as well. So I'm going to open up a new tab in my browser because I don't have a calculator on me. I'm just going to try to Google, what was it, 26,400 over 2 pi. Let's see what it tells me. I get 4,201.69. All right, cool. All right, and it looks like everyone is in agreement with that now. Well, maybe that's good. All right, so then if your professor wants a whole number of revolutions, you might round that up then to 4,202. Okay. Yeah, all right, good. Okay, so part C is asking for the linear speed of the bike. All right, does anyone remember what linear speed is?
Is it distance times time?
Very close, okay? You're on the right track. It's not distance times time, though. It would be distance over time.
Oh, yeah.
Mm-hmm. Okay, yeah. So, and then I'll talk about that afterwards. But yeah, so linear speed, you can calculate it as being the distance divided by the time. A good way to keep that in mind is, as you know, maybe units of speed should be like something like miles per hour, so like a unit of distance over a unit of time, right? Okay. So what we know is that you traveled a total distance of 10 miles in a time span of 35 minutes. So then we can calculate the linear speed as 10 miles, the total distance traveled, over time of 35 minutes. All right, and didn't really specify what units we want the answer in, but let's say for the purpose of this video, if I wanted the answer in miles per hour, which is maybe how we're most accustomed to measuring speed because we drive cars and stuff. So then you need to do some unit conversion to get the answer in miles per hour. All right, so to do that, let's see here. 1 hour is 60 minutes. All right. So then we would do 10 times 60 divided by 35. Okay, and then 600 divided by 35. It's about 17.14 is what I'm getting. All right. All right, and then, so that's the linear speed, and finally, part D is asking for the angular speed. And someone already posted the equation, posted in the chat the equation relating angular speed to linear speed. So linear speed v is related to the angular speed, which people typically use the Greek letter omega, which looks like a W for angular speed, times the radius, okay? All right. So since we have the linear speed from part C, and we know the radius of the bike wheel was 2 feet, we can solve for the angular speed as being v over r, which would then be, well, so we have 17.14 miles per hour. But let's see here. Well, maybe I'll do that right now. But yeah, we are dividing by the radius, which was 2 feet. Okay? All right. So what we do need to do then is either convert miles to feet or feet to miles. Okay. Oops. So maybe what I'll do then is I'll move that hour to the denominator since it was being divided. And then converting miles to feet, we know that 1 mile is 5,280 feet. Okay? Yeah. So yes, you can also do that as well. Okay? So let's see here. Maybe what I'll do is I'll finish this up and then we'll also take a look at that. Okay? All right. So yeah, so you could calculate the angular speed like this, using the relation between angular speed and linear speed. So what we'll get from this is that it should be 17.14 times 5,280, and all divided by 2. And so right now the units of this was going to end up being radians per hour. And yeah, so you could have done this another way as well. So instead of using the relation between linear speed and angular speed, okay? Another way you could have calculated the angular speed is using similar idea. If you calculate linear speed as the distance over the time, you can calculate angular speed in a similar way. And the angular speed would be the angular distance over time, okay? So angular distance, you could use the answer that you calculated in part A for the angle. And then divide by the time of 35 minutes that was given. Okay. All right. And so here, this should give you the same answer as well. So there's kind of maybe two ways then of figuring out the angular speed. And you can get the answer in like radians per hour or radians per minute or even radians per second by doing the appropriate dimensional analysis, all right? I think I'll go ahead and maybe stop at this point though. I think that's good enough. Let's take a look at problem number 11, okay? All right, so I want to take a look at problem number 11, and then I also want to loop back around to problem number 6 since there was a specific request for that, okay? All right, so problem number 11, so you guys are kind of just starting to talk about all the different trigonometric functions, cosine, sine, tangent, secant, cosecant, and cotangent. Okay. So here I'm going to draw just a little picture of what we have given in the problem. So we have this angled data in standard position, and it's passing through this point 5 root 3 over 2 and negative 5 halves. Okay, so I'm going to just roughly plot that point in this picture. So the x-coordinate is positive and the y-coordinate is negative. So it'll be maybe somewhere down here in the picture, okay? Now when they say that we have an angled data in standard position, what that means is the angled data represents the angle measured starting from the positive x-axis and moving in a counterclockwise direction. That's what they mean when they say that the angled data is in standard position, okay? Standard position means start from the positive x-axis and go counterclockwise. So we have a really big angle right now for data. And then we're asked to calculate the cosine of this angled data, the sine of the angled data, and so forth. All right, how do I calculate the values of these trigonometric functions? Who can tell me that?
We need to use the Pythagoras theorem because we need to make a
Mm-hmm.
triangle there on the.
Yeah.
I don't know if it's correct to say we need to make the triangle on the unit circle, but on the diagram itself, we need to make a triangle. Then use
Okay. Yes. Uh-huh. Right. Okay, good. So let's start with that first, okay? All right. So what we can do is if we make a right triangle with the x-axis and the point that we were given, okay? One thing that we need in order to calculate some of the values of the trig functions is we need to know the length of this hypotenuse, okay? So to calculate the length of the hypotenuse, well, we know the length of this edge would have been given by the x-coordinate of our point. Now the length of this edge, you could get it from the y-coordinate, which is negative 5 halves, okay? The actual length itself is positive 5 halves, because length is positive, but the y-coordinate is negative. It doesn't matter so much because if you want to get the length of the hypotenuse, you would use the Pythagorean theorem. So let's see here. So to get the length of the hypotenuse, you would do, well, I guess I can switch colors. The square root of x squared plus y squared. Okay. In order to get the length of the hypotenuse, I'll make a little bit bigger. So we need to do 5 root 3 over 2 squared plus, and since I'm squaring, the negative doesn't matter, so I'm just going to do 5 halves squared. Okay. All right, so let's simplify this a bit. All right, so first, to square this fraction, we will just square everything in the fraction. So it's going to be 5 squared is 25 times the square root of 3 squared, which would just be 3, over 2 squared, which is 4. Likewise over here, 5 halves squared would be 5 squared, which is 25, over 2 squared, which is 4. Alright. 25 times 3 is 75, so we have 75 over 4 plus 25 over 4. So that gives us 100 over 4. Which will give us 25 altogether. And so square root of 25 is a nice number, just 5. Okay, good. So now we have the length of the hypotenuse is 5. So let's write that in the picture. Okay. Now that we have the hypotenuse, how do we use that to calculate cosine and sine to start with?
We need to have memorized the formulas for sine, cosine, and so like sine equals opposite divided by hypotenuse, tan equals divided by adjacent, and we have the values for all of the sides now, so we can fill those in.
Okay, yeah. So for getting cosine of the angle theta, so you can calculate the cosine of theta as the sort of the adjacent side, sort of. So x over the hypotenuse. Okay. Whereas for sine, you can calculate it by taking sort of the opposite side, which would be y over the hypotenuse. Taking the y coordinate dividing by the hypotenuse gives you sine. Taking the x coordinate dividing by the hypotenuse gives you cosine, okay? So we'll start with these two first. So cosine, let's take the x coordinate divided by the hypotenuse, okay? All right. So to simplify this, we are dividing by 5. So you can simplify it by rewriting it as, so you're dividing by 5 is the same as multiplying by 1/5. So multiplying by the reciprocal, okay? So when we do that, to simplify, what we can do is to cancel out the 5s. So look at sine of theta, or sorry, cosine of theta rather, should be square root of 3 over 2, okay? That's the value of cosine theta. As for sine theta, we take the y coordinate and divide it by the hypotenuse. So here the y coordinate was negative 5 halves. So we do include the negative for this, and then divide that by hypotenuse, which is 5, okay? So again, dividing by 5, you can write it as multiplication by 1/5. The 5's cancel. So let's say you get a final answer for sine of beta as being equal to negative 1/2. Okay? Alright, so what about tangent? What can we do with tangent?
That's opposite divided by adjacent.
Okay. Yeah, so we can do sort of the opposite over the adjacent. Was someone going to say something else? Okay. Yeah, so that is correct. You can do tangent as being the opposite over the adjacent. So for the opposite, we would use the y-coordinate for the opposite, and we're going to use the x-coordinate for the adjacent, okay? So then you can say it would be like an opposite over adjacent. You can say it would be the y-coordinate of our point divided by its x-coordinate. So let me see here. The y was negative 5/2. Okay. Divided by the x, which was 5√3 over 2. Okay. So we'll simplify by multiplying by the reciprocal. All right. So here to simplify, some more, the 2's and the 5's will cancel. So that's going to leave us with negative 1 over √3, okay? And if you guys need to rationalize, so if you don't want the square root in the denominator, you can multiply top and bottom by square root of 3 to write it as minus √3 over 3, okay? So then that would be the final answer. My suspicion, if it's in my math lab, is that this would also be an acceptable answer as well, okay? All right, that's good. So we have cosine, sine, and tangent. What about the others? Secant, cosecant, and cotangent. What would we do with those?
Cotangent is simply the inverse of tangent, and cosecant is the inverse of sine, and the last one is the inverse of cosine.
Yeah, okay. So secant of beta is just the reciprocal of cosine. So that means it would just be 2 over √3. Cosecant of beta is the reciprocal of sine. So it would just be negative 2 over 1 or negative 2. And finally, cotangent of beta is the reciprocal of tangent. It would just be, if I maybe reciprocate this one, it would just be minus √3 over 1, or just minus √3. Okay. So then these would be acceptable answers, or at least these are correct answers. If you need to rationalize this one, again, you can multiply top and bottom by √3, and put that as 2 √3 over 3. Okay? All right, good. All right, so any questions about that?
I have a question, but it's kind of unrelated. So,
Sure, okay.
will we be getting a copy of these like worksheets and quick notes like after the practice is over?
I could do that. I could, I think export this as an image, I think, and send it out to you guys. Okay?
Okay, perfect.
If
Thank
not,
you.
I can, yeah. Exporting as an image might not work so well, so instead I might also just snip everything and merge it all together, okay?
Okay, thank you.
Yeah, because I've done exporting images in OneNote before, and it does this weird thing where it cuts off your work into if I were to export this page as an image, like the right half would be cut off and put onto the second page, and it's very awkward. So I'll probably snip everything instead, and yeah, okay. All right, so that was problem number 11. I'm just going to take a look at problem number 6, and then I'm going to go ahead and wrap things up after taking a look at number 6, okay? So number 6 was about checking whether a function is even, odd, or both or neither, okay? Let's just quickly talk about what it means to be odd and even. So algebraically, a function is even if it satisfies f of minus x equals f of x. Okay? And what it means for a function to be odd, at least sort of like an algebraic definition, is that f of minus x equals minus f of x. Okay? Now, although it's not important for this problem, it's maybe good to see that you can kind of recognize whether a function is even or odd from a graphical perspective. So if a function is even, then its graph will be symmetric about the y-axis. So it'll be something like this. Now, as for an odd function, the graph of an odd function will look something like this. It'll be similar to the graph of the cubic function. So here's one example of what an odd function would look like. Okay? All right.
So a graph symmetric about the origin is going to be an odd function.
Yeah, so if the graph is symmetric like this about the origin, then it's going to be an odd function. Okay. So that's kind of good to know, I think, graphically what an even function and an odd function looks like. Now for this problem, you don't have the graphs, so you're going to have to verify algebraically whether they were even or odd. Okay? Now a function can be neither if it satisfies neither of these properties. Okay? I'll go ahead and say right now that the only function which is both even and odd answer. All right. So it's just sort of a special case, if you will. So the only function that is both even and odd is a function that's always equal to 0. Okay. So unless one of your questions is the zero function, you should never give an answer of both, okay? So if one of the questions is f of x equals 0, it's both even and odd. If it's anything else, the answer will not be both. It'll either be even or odd or neither instead, okay?
I believe our professor told us that, if I remember correctly, that we would not get any option where it would be both even and odd, but I guess this is the only extreme exception.
Yeah, this is the only possibility. So the only way you could have a question where the answer was both was if you were given this function, it's just always 0, okay? So yeah, so basically you don't have to worry about the answer ever being both pretty much, okay? So let's take a look at a few of these problems. So let's take a look at A to start with. So here's how you check whether a function is even or odd or neither algebraically. So we're given, our function f of x is 1 minus 2x squared. So what you want to do is you want to compute f of minus x, okay? And so to compute f of minus x, what you do is you replace each instance of x with a minus x, okay? So instead of x squared, we would have minus x squared. All right, and then we're going to simplify this. Minus x squared is actually the same as just x squared, right? Because when you raise a minus to an even power, the minus sign just goes away, becomes plus. So what we see then is f of minus x, after simplification, it turns out to be equal to f of x, right? Because f of minus x equals f of x, that means that we have an even function, okay?
I don't mean to skip ahead, but could we do
Yes.
if that's all right?
We might as well maybe because that's the only other question, right? But yeah, let's do a couple more from part 6 at least, all right?
All right.
Let me see here. So we did A, let's just take a look at B next, all right? So it'll be the same thing. We have the function f of x, which was x squared plus 4x plus 1. So I'm going to replace each instance of x with a minus x to calculate f of minus x. So instead of x squared, it's minus x all squared. And then instead of plus 4x, it'll be plus 4 times minus x plus 1. So if we simplify this, that's going to be x squared minus 4x plus 1, okay? And notice this time that f of x is not equal to f of minus x, okay? It's not even. Okay, so f of minus x is also not equal to minus f, right? Because what would minus f be equal to? like minus f of x would just be negating the entire function f. And so that minus f would distribute to every term. So you can see that's not the same as f of minus x. So because those are not the same, it's also not odd. Okay? So in other words, this function is going to be neither even nor odd then. Okay? All right, let's see here. I'll do two more. So let me do the last two. I'll do E and F, okay? Just to take a look at those two guys. So E, we have the function 3 minus 2 times the absolute value of x plus 2. Okay, so we're going to need to compute f of minus x to compare with f of x. Okay, so again, to get f of minus x, you replace each instance of x with a minus x. Okay? So instead of x, we have a minus x now. And I guess let's also take a look at minus f of x, because we also need to compare it with that. So we would just negate everything in f of x, so it would become minus 3 plus 2 absolute value of x plus 2. Alright, so comparing f of minus x and f of x, are these two equal to each other?
No.
Yeah, they are not, okay. So it's not even. Are they, is f of minus x the same as minus f of x? Okay, so also no. So therefore it would be neither even nor odd. Okay. Actually, now that I think about it, so that was E, right? Maybe it's good to take a look at D real quick as well, because that also involves absolute value, just as a comparison. So I'll do D and then I'll do F. So D was a little bit simpler. It was just 2 absolute value of x plus 3. So f of minus x would be 2 absolute value of minus x plus 3. So f of minus x, is that the same as f of x?
No, they're not the same.
Okay. So yeah, so I do want to make sure you guys get this part down. So here they actually are the same, right? Because remember, like what does absolute value do? Like absolute value would just like make something positive, right? So if you have a minus sign in front of the x, the absolute value is just going to like get rid of the minus sign in the end. Like it's not going to matter.
Yeah.
Like absolute value of minus x would be the same as absolute value of x. Okay. So in fact, f of minus x actually is the same as f of x, okay? So that actually means that this is an even function, okay?
But does that mean for part E,
Uh-huh.
doesn't that change f of minus x? Shouldn't it be equals to 3 minus 2? The minus x will turn into positive x.
Okay, yeah. So the answer is no, okay? So the reason why is because the plus 2 kind of ruins it. So let me try to explain why by illustrating over here. Okay, so in general, when you have absolute value of the negative of something, okay, you can just ignore the minus sign because the absolute value will just cancel out the minus sign, okay? But when we look at what's going on over here, all right, what you could say is this. Maybe I'll use red, okay? You could say that absolute value of x plus 2 is the same as the absolute value of its negative, okay? Because again, the absolute value would kind of cancel with this minus sign. So it would just give you kind of the same thing, okay? But notice that negative x plus 2, if you were to distribute the minus, is absolute value of minus x minus 2, right? So these are actually equal to each other. But if you just have the minus in front of the x and not the 2, then it's not the same thing, okay?
Yeah, it makes sense. So if I were to think of it simplistically, if we have anything else
Mm-hmm.
in addition to the x value inside our absolute function, or I'm not sure what to call that part where you
Mm-hmm.
draw the two lines. So if we have anything other than an x inside there, we can't like um, it ruins the ability of the x to turn
Mm-hmm.
positive if it happens to be a negative.
Yeah. Yes, okay. So yeah, so if you have x by itself, then when you do f of minus x, the minus sign just kind of goes away because of the absolute value. But if you have like a number like added or subtracted to the x, that's going to ruin things. So it'll most likely not be even or odd. Okay.
Right.
All right. So yeah, so I'm glad that I did go through D as well. Let's take a look at F just to cap this one off. All right.
All right.
So in part F, we have x over x squared plus 1. Okay, so let's take a look at f of minus x. So replacing each x with a minus x will give us, minus x on top. And that'll give us minus x squared plus 1, okay? All right. But remember, like minus x all squared is the same as x squared. So this squared also kind of gets rid of the minus sign. So it's actually minus x over x squared plus 1, okay? So is f of minus x the same as f of x?
Nope.
Okay. Nope, but what you notice though is it's the same except the minus sign in front, right?
Yeah.
So you could say f of minus x was really minus f of x then, do you see?
Oh, I see.
So this would be an example where you have an odd function, all right?
Yeah, we pretty much like we solved both odd and even. We proved it's not odd and sorry, we proved it's not even and it is odd in just one calculation. this
Yeah,
case.
that's right. Okay. Yes, yes. Okay.
Yep.
All right, great. And there's only one question left, so we might as well go through it. Problem number 8, and it's a pretty quick one too. So let's take a look at number 8.
This is a composition function, right?
That is correct, yes, okay? Alright, so we have these two functions, and we first want to like f composed of g. So this is like the same as f evaluated at g of x. Okay, so let me see here. G of x was 5 minus 2x. So what we want to do is, in the formula for f, we need to replace each instance of x with 5 minus 2x instead, okay?
Yep.
So in the numerator, instead of just x, it's now going to be 5 minus 2x. And in the denominator, instead of x squared, we replace that x with a 5 minus 2x. So 5 minus 2x squared, and then plus 1, okay?
Yep.
All right, perfect. Let me see here. We also wanted to g compose with f, right? Okay. Was g of f of x. So what this means is take the function g and plug in f, which is x over x squared plus 1. Okay. So anywhere we see an x in g, we're going to replace it with x over x squared plus 1. Okay? So instead of 5 minus 2x, that x gets replaced with x over x squared plus 1. Okay?
Yep.
All right. And so, and then I'm not sure in terms of like maybe how much simplification you might want to do. There's not much you can do, I would say. You could multiply the 2 into the fraction if you wanted, like that. Up here, the only thing you could really do, I think, is follow out the parentheses. That I'm not sure if that would be considered more simplified, though. Okay.
And I
Right.
thought that the 2 won't be distributed to the denominator.
No. So you can kind of think of it as like 2 is the same as 2 over 1.
Oh, okay, yeah, that makes sense.
Yeah. Okay. Yeah. Okay. Yeah. So it only goes into the numerator in that kind of situation. All right.
Yep.
Okay, cool. So I'm gonna go ahead and stop the recording now. Whoops, wrong button.